integral, evaluation of improper integral, improper integral, evaluation of an improper integral of the form what? Type, what is it? Minus infinite to infinite fx dx. And if some singular points lie on a real axis. So, if some point lie on a real axis, then how we solve this one? So, here, if fx means a rational function px upon qx and there is no any common factor between px and qx. So, how we evaluate this type of integral? So, first we write what? First we write equivalent. Equivalent what? We write the equivalent complex integration. Complex integration or contour integration. So how we write this one? Integrate over C fz dz. Fz dz. So what is the property of fz? Fz is in form of what? Pz upon qz. Qz in form of a numerator and denominator. So, and what is the first condition? Fz is analytic, not Fz have only. We write here Fz is what? Fz is analytic. Fz is analytic inside and on the real axis except finite number of point, number of a singular point, isolated singular point, and that single point is what? Poles. Lie singular points, finite number of isolated singular points z1 star, z2 star up to what? Zk star lie inside the upper half plane, inside the upper half plane and Z1, Z2 up to Zm lie on a real axis. Real axis means there are two type of singular points. First type of isolated singular point means poles lie inside the upper half plane, and second type of a singular point which is a poles lie on a real axis. What is the condition with the Pz and Qz? The degree of a denominator, as usual in a previous methods, the degree of a denominator is at least 2 units higher than the degree of a numerator. So I am not here writing this one. The degree of a denominator is at least 2 units higher than the degree of a numerator. So what is the C? If we talk about the C is a what? C is a look like this one. This one look like this one. Means here, this one, and this one is a minus R, and this one is a what? This one is a plus R. So there is a use of this one, so I am not going to draw here. I am going to draw here because there is a use of this curve. So what is the C? C is here. This one contain like this one, means this one is a C, this one is a minus R, this one is a R, and this one is a what? This one is a CR, and here there is a Z1 star, Z2 star, means these singular points lie inside upper half plane. This one, ZK star, and these singular points Z1, Z2, Zm lie on this one, Z1, this one is Z2, and similarly here Zm minus 1, and here this one is what? Zm. So here we draw a small circle like this one, which exclude the Z1, very small circle, and here very small circuit which exclude the Z2, here very small circuit which exclude the Zm minus 1, here very small circle which exclude the what? Zm. And orientation of this one is the what? Orientation of this one. This one. This one is the orientation. 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 And suppose this one is the I1. This part is the I1, and this one is the what? C1. This one is the I2. This one is the C2. Similarly, this one is the Im minus 1. Im minus 1, and this one is the Cm minus 1. Cm minus 1. This one is the Im, and this one is the Cm, and this one is the what? Im plus 1. Im plus 1. So C divided into a what? C divided into a Cr plus I1 plus C1 plus I2 plus C2 up to what? Cm plus Im plus 1. Im plus 1. So C divided into these parts. So we may write this one is the Cr plus summation Ij equal 1 to m Ij plus summation I equal 1 to m plus 1, 1 to m Ci. So this one is the value of what? C. So what is the integration? Now integration become, we know that integral of this one is a what? Integral of this one is a integration of integrate C fz dz equal what? 2 pi I sum of the residues which lie inside this upper half plane, inside the upper half plane. The points which lie inside the upper half plane, Z1 star, Z2 star up to a Zk star. 2 pi I equal 1 to k residue of fz at Zi star. Zi star. So this one is a value of 2 pi I. Now we divide the C into this part, m plus 1 and m, and this one m plus 1 and 2m plus 2 parts. So now C can be divided into a Cr fz dz plus summation j equal 1 to m plus 1 Ij here I am not writing Ij, here in form of integration we write integration in form of integration. In form of integration, this one is a Ij fz dz plus summation I equal 1 to m integrate over Cj fz dz equal what? 2 pi I sum of the residues. 2 pi I sum of the residues. Sum of residue at z equal z star. Z equal z star. Now, as r tends to infinite, then what will happen? As r tends to infinite, then we know that, as earlier we discussed, This one become what? This one become C. Integrate over CR FZ DZ tends to what? Tends to C. Now, what is the value for this one? This one become integrate Z summation J equal 1 to M plus 1 IC. So as R tends to infinite and this circle, radius of this circle tends to 0. Suppose the radius of this circle is a epsilon. This one is a epsilon. So as R tends to 0 and epsilon tends to what? 0. Epsilon tends to 0 means the radius of this circle C1, C2. Here we assume that the radius of this circle is very small. And we assume that the radius of this circle is what? Epsilon tends to 0. Then this integration become what? This integration become infinite to infinite fx dx and this one equal 2 pi I sum of the residues summation I equal 1 to k residue of fz at z equal zi star. This one is the first term minus integrate over what? This one. Integrate over, if we write in term of a summation, I equal, here this one is the Ci, I equal 1 to m integrate over Ci, if we write this one is also a j because j equal 1 to m, both have the same meaning. This one is Cj, you may write this one Cj, Fz, dz. So we able to find out this one. Once we able to find out this one, then we say that integrate minus infinite to infinite fx dx equals this one. Now we try to show that what is the value for this one. So what is the value for this one? Here we try to write this here. We try to write here and we try to prove this one basically. So what is the proof of this one? Means if we write this one is a what? This one is a I dash. Here we write what? I dash. This one is a what? I dash. Now what is the value of I dash? I dash become what? I dash become integrate over, here we write the first summation. What is the summation? I dash equal summation j equal 1 to m integrate over Cj Fz Tz. Now what is the Cj? Cj is a C1, C2 like this one. So Z1, Z2, Z3, Zm, Zj is a what? Poles of order 1. Pole of order 1. So how many number of if we expand this one is as a Lorentz series expansion, how many number of a term in a Lorentz series principal part? There is a one term. So Z equal, let Z equal Zj be pole of order 1, then Fz can be written as A0 plus A1 Z minus Zj up to infinite number of a term plus B1 upon Z minus Zj. Means Fz can be written as what? Fz can be written as, suppose this one is a what? This one is a Gz. Gz plus B1 upon Z minus Zj. So here we replace this one. Integrate over Cj become what? Fz can be replaced by this one. Gz plus B1 upon Z minus Zj, Zj whole, this one become what? Dz. So here we write this part. This one is integration. Now what is the value for this one? Here we assume that Z minus Zj equal epsilon e to power I theta. And theta varies from what? Theta varies from, here orientation of a C1 is what? Clockwise. For this reason. So this one treated as a minus C1, so theta varies from pi to what? Pi to 0. Pi to 0. So If we put here, then this become what? Integrate over Cz. What is the value of a Gz? Gz become G of Z become what? Z become G of a Gz. This one is a Zj plus epsilon e to power I theta. And what is the value for dz? Dz become what? Epsilon into e to power I theta into I into d theta. So what is the value for this one? This become epsilon into e to power I theta into I d theta, and this one the here theta varies from pi to c. This one is a gz. What is the second one? Here this one pi to 0. This one v1 upon z minus zj. This become what? Epsilon e to power I theta into dz, epsilon e to power I theta I d theta. So this one epsilon e to power I theta, epsilon e to power I theta cancel out. So what is the value? Value become what? So, and here as epsilon tends to 0, then if you closely observe, this integration tends to 0. Means the first integration, this one tends to 0. What is the value for this one? b1 into I. And what is the, this one pi to 0. So if we integrate with respect to theta, what is the value for this one? This one becomes b1 into I minus pi I, minus pi. And b1 is what? b1 is the residue. Residue at z equal zc. So what is the value of integration? This become what? This becomes 0. This become minus pi I residue of, here we write summation notation also, pi I outside, summation j equal 1 to m residue of fz at z equal zj. So here we put the value for this one. So what is the value of integration? Here we put the value of I dash. If you put the value of I dash, this one is with negative sign. So here with negative sign, this become a positive sign. So what is the value of integration? Value of integration become 2 pi I summation I equal 1 to k residue of fz at z equal zi star plus pi I residue of summation j equal 1 to m residue of fz at z equal zj. So what we conclude here? We conclude here, integrate minus infinite to infinite fx dx if the singular point lie inside the upper half plane, then we find the residue of upper half plane multiplied by 2 pi I, and the singular point which lie on a real axis, we find the residue at that point multiplied by pi I, and then this one is a what? This one is a value of integration. Only remains to show what? R tends to infinite, integrate over C R as dz equal 0. So this one is a what? This one is a theoretical concept of if some singular points lie on a real axis and some singular points lie inside a half or half plane, then how we find the value of integration. So now we evaluate a improper integral in which some point lie on a real axis, some singular point lie on a real axis, and some singular point lie inside the upper half plane. Suppose we consider I equal minus infinite to infinite sin ax divided by x into x square plus b square dx is a greater than 0 and b is a greater than 0. So we try to find out this one. We write equivalent form of this one is a what? Equivalent form means we write this one like this one means minus infinite to infinite, imaginary part, imaginary of what? Minus infinite to infinite e to power I ax divided by what? X, x square plus b square dx. So we write the equivalent complex integration. This one I equal integrate over c f z dz, where f z is what? E to power I z divided by z square plus b square. So what are the singular points here? What is the value of a c? C is this one. Here there is a one point z equals 0. How many number of singular points? Z equals 0 with a singular point, and z equal plus minus I. Plus minus I. Then I will lie upper half plane and z equals 0 lie on a real axis. So z equals 0 here, z equals 0 lie on a real axis. So this one is a what? This one is equal to C. Here this one is a CR, and this one is a plus R, this one is a minus R, and here one another curve. And suppose this curve is a what? C1. This curve is a C1. And suppose this one is a L1, and suppose this one is a radius of this one is a epsilon. This one is a minus epsilon, this one is a plus epsilon, and this one is a L1, and this one is a what? This one is a L2. This one is a L2. So now what is the value of integration? Integrate over C fz dz become what? 2 pi I residue of fz at z equal what? Z equal bi, because this one lie inside. Bi plus bi lie inside. Z equal bi. So this will become what? 2 pi I residue. This one is a pole of order 1. Pole of order 1. So limit z tends to bi, z minus bi into e to power I a z divided by z into z plus bi and z minus bi. So this one cancel out. If we put the value of this one 2 pi I, and this become e to power I a z is a bi divided by what? Bi, and this become 2 bi. So what is the value of this one? This become e to power minus ab, I square become minus 1, and 2bi this become what? I square become minus 1 minus 2, and this become 2 pi I, 2 and 2 cancel out, and this become pi I into e to power minus ab divided by, this one is a residue of a fz. Residue of a fz inside this point, inside this upper half plane. Now what is the value of a c? C can be traced as what? CR plus L1. This can be written as what? CR fz dz plus integrate over L1 fz dz plus integrate over C1 fz dz plus integrate over L2 fz dz equal what? Equal this one minus pi I e to power minus ab divided by b. Now what is the value for if r tends to infinite? If r tends to infinite, then this can be written as what? This can be written as a, here L1 can be written. First we write in a what? In a real integral form. So this become integral this one minus r to minus epsilon fz dz plus integrate over C1 fz dz plus epsilon to L epsilon to R fz dz equal what? Minus pi I e to power minus ab divided by b plus minus integrate over CR fz dz. So now as r tends to infinite and epsilon tends to 0, then we know that what is the value of integration? Integrate over C1 fz dz. Fz dz become what? Minus pi I residue of a fz at z equal 0. At z equals 0, because z equals 0 lie on a real axis. This one, z equals 0 lie on a real axis. So what is the residue at this point? Residue at this point become minus pi I limit z tends to 0 z into e to power what? E to power I a z divided by z into z square plus p square. Z cancel out, z tends to 0. Then what is the value? Minus pi I. Z becomes 0, so this becomes 1 e to power 0 divided by what? B square, because z becomes 0. So what is the value? Value becomes minus pi I divided by what? B square. So what is the value? So if r tends to infinite and epsilon tends to 0, then this becomes minus infinite to 0 and this one 0 to infinite. So we combine this one and this one. This become what? Minus infinite to infinite fz dz. And what is the value of integration? Value of integration is this one, minus pi I b square. So minus pi I, so this become what? Pi I minus pi I e to power minus ab divided by b square minus pi I divided by what? Divided by b square. Divided by b square. Divided by b square. Minus pi I divided by b square. So this one become pi I b square. Pi I b square. So minus infinite to infinite, this one is a minus pi I, so this become right hand side and this become what? Plus. Minus integrate over CR fz dz. So if this one tends to 0, obviously this one tends to 0 as r tends to infinite. Here I am directly right, this one the value of what? This one tends to 0. This one tends to 0. So what is the value of integration? Value of integration becomes minus infinite to infinite fx. Here we write fx, not if we write in a real analysis, then this becomes minus infinite to infinite fx dx equal what? Pi I upon b square outside, then this becomes 1 minus e to power a. This one is the value of integration. So this one is a value of integration. Only need to show what? Only need to show what? Integrate over CR fz dz tends to 0 as r tends to infinite. So what is the value of fz? Integrate over CR, suppose this one is I dash, CR fz dz. Fz become what? E to power I a z divided by z square plus b square dz. Taking mod both sides, then this become, and using this one, z equals r into e to power I theta. Taking a mod of this one, mod of z equals mod of r, and mod of dz equals mod of r into mod of d theta. So I become what? Mod of I dash is less or equal to 1 upon r into r square minus b square into dz become mod of r into mod of d theta. integrate over d theta. And what is the value of theta? Theta becomes 0 to 2 pi. So if r tends to infinite, then this one tends to what? This one tends to 0. So because the value of integration is this one is a 2 pi. So this one is all about this lecture. So we solve in this way. First we find a what? First we find a residue inside a point, and then we find the residue on a real axis. Then 2 pi I sum of the residue inside and pi I sum of the residue on a real axis. Thank you. Thank you.